Hi friends, today we will going to discuss about equilibrium constant and its units. I hope you all are ready to listen carefully. Equilibrium constant is a ratio of the product of concentration of products raised to the power of coefficient to the product of concentration of reactants raised to the power of coefficient. Now what it means? Basically, equilibrium constant is a ratio between two statements. According to the law of mass action, we have to take product in the numerator and reactants in the denominator. Now in the numerator, product of concentration of products means that we have to take the product or we have to multiply the substances which are formed by the reactants. In common words, we use the name product for them. And the number of moles which are present in the product will act as the raised to power of coefficients. While in case of reactants, we have to take product of the concentration of reactants and the number of moles which are present in the reactant will act as a raised to power of their coefficients. What is the importance of equilibrium constant? Definitely, in a balanced chemical equation, in any dynamic equilibrium, for a reversible reaction, we can get an equilibrium expression. We can quantitatively measure our equilibrium constant, our dynamic equilibrium, if we know the numerical values. By putting these numerical values in this ratio, we can get the actual concentrations of the reactants and products when they achieved their equilibrium. Equilibrium constant depends upon temperature. It doesn't depend upon the initial concentrations of the reactants and products. Don't you think why? It depends on temperature because if we increase the temperature, the energy of the molecules will increase. And definitely, if energy of the molecule will increase, the dynamic equilibrium will disturb. So we don't have to disturb our temperature if we don't want to disturb our equation or our dynamic equilibrium of our chemical reaction. So we can easily understand that the equilibrium constant is temperature dependent. Here I am discussing the units of equilibrium constant. So when number of moles in the reactant and the number of moles in the products are equal, equilibrium constant has no unit. For example, 1 mole of hydrogen and 1 mole of iodine reacts together to form 2 moles of hydrogen iodide. Now in this expression, in this chemical equation, 2 moles are present in the reactant as well as 2 moles are present in the product. They both will cancel each other and the Kc has no unit. While for the reactions in which the number of moles of reactants and products are not equal in a balanced chemical equation, definitely K have units. For example, 1 mole of nitrogen and 3 moles of hydrogen reacts together to form 2 moles of ammonia. Now how many number of moles are present in reactant? Yes, you are right. 4 number of moles. 1 of nitrogen and 3 of hydrogen. And how many number of moles are present in a product? 2. So when we will put this in an equilibrium expression and simplify it, we will get an answer or we will get the unit of equilibrium constant. In case of units, as we know that we are dealing with the active masses of the molar concentrations of the reactants and products. And I have told you in my previous lectures that active masses will be measured in mole decimeter cube inverse. So in the case of units, we have to put mole decimeter cube inverse for the reactants as well as for the products. In this way, we can find out the value of Kc or the units of. This is the same reaction. Nitrogen and hydrogen reacts together to form ammonia, Haber's process. A reversible reaction taking place at 500 Celsius. Now, here is the equilibrium concentrations of these gases. How can we get these equilibrium concentrations? We can get this by plotting a graph between time and rate of a reaction. What is rate of a reaction? Rate of a reaction is the speed of a reaction. And if speed of a reaction is time dependent, then definitely at any time we can find out the molar concentrations of the reactants as well as products. So here the equilibrium concentration of the gases are given. We will put these concentrations in the Kc expression. The number of moles which are present in a balanced chemical equation will become raised to the power of the coefficients. So by solving the equation, we can get the value of Kc. Now why the value of Kc is important? It is important because it tells us about the direction of a reaction, whether the reaction is going in a forward direction or in a reverse direction. It also tells us that how much amount of reaction has taken place. So this is all about equilibrium constant and its units. Thank you.